Everyone, September 9th. I took a day off today, so no training. And actually finished work a little bit early as well. About an hour ago, and I watched videos for about an hour, and hopefully afterwards I don't watch again and I'll go back to reading. But anyway, so that's kind of how it is where we are now. I switched the training program a little bit. I cannot do the Seeker strength anymore. Too much volume, man. It's way too much volume. I cannot handle it. All right, let's take a look what we have today. Minimal number of people to teach on a social network consisting of M users and some friendships between users. 2 users can communicate with each other if they know a common language. You are given an integer n, an array languages, and an array friendship where there are n languages, number 1 through n. Languages I is the set of languages the ith user knows, and friendship denotes a friendship between the 2 nodes. You can choose one language and teach it to some users so that all friends can communicate with each other. Return the minimum number of users you need to teach. Note that friendships are not transitive, meaning if X is a friend of Y and Y is a friend of Z, that does not guarantee that X is a friend of Z. So basically this means friendship is only existing in that array. So those are the edges, and that's it, right? That's it. So we have these connections between nodes, and language just means if they can communicate, right? If the edge is legit, right? We have some edges, but some of them are not legit at the beginning. And what we want to say is we'll choose one language. So it's like they have a different category, right? Have different categories. And actually maybe it'll be easier just to draw it out. N equal to 2. What is n again? N is a number of languages. So we have 2 languages, right? So we have node, we have 1. 1 will go to 2, and 1 will also go to 3, and 2 go to 3. But that's the friendship. And then we all put language on top of it. So language I is set of languages that ith user know. We have a 0th user? 0, 1, 2? The friendship between users UI and VI. So user is 1, but we have a 0. Wait a second. Languages are from 1 to n. Languages I is the set of language the ith user knows. So we have 3 users. A friendship I denotes a friendship between user U and V. So we have user 1, 2, 3. I think there is some issue with the indices, because this UV is 1 based, I is 0 based. Like, what the hell? So I think this is the first user, this is second user, third user. So first user knows 1, second user knows 2, third user knows 1 and 2, right? So what we want to do is to choose one language and teach it to some users so that all friends can communicate. So communicate means we need the 2 nodes to share at least one language. So if they share, that means they already talk to each other. So here they talk, but they don't. So we can find the ones that they don't, and then we say we will basically change this into a different value so that these can talk. And let's see another example. So 1 to 4, 1 to 2, 3 to 4, 2 to 3. So 1 to 4, 1 to 2, 3 to 4, and then 2 to 3. Language-wise, the first one is 2, second one is 1, 3, third one is 1, 2, fourth one is 3. So what will be the change? And language is 3, so I have 1, 2, and 3. N is 500, so I have 500 languages. Language is our length, so that's the number of people. So I have 500. Can we just say, we'll teach people 1, language 1. So if you have 1, you don't have to teach. Otherwise, you have to teach. So if we teach these 2 1, then everybody can communicate. Okay, now let's say if we teach people 2. So we need to teach these 2 people 2, so that's 2. If we teach 3, we have to teach these 2 3. So, maybe that is. Maybe that is. Because we need to guarantee that after we teach, every pair of nodes will share the same, like there has to be one number shared among everyone. Then what is this friendship? I don't even need this friendship. Why do we need this friendship? What was the purpose of this friendship? Right? The purpose of the friendship is you don't have to have everyone share the same language. All you want, hold a second. All friends can communicate with each other. All friends can communicate with each other. So okay, here's a scenario. Right, 1 can communicate with 3. 3 can communicate with 2, but 1 and 2 are not. That's what it says. Right, they cannot communicate. But how about this? Let's say they can communicate in a language. So let's say 1 2 1 2. Hold on. What are you trying to do? What I'm trying to do is to find, like, if these 2 people communicating one language, but they communicating a different language, right? So if this is 1 2, let's say this is 3 2, and this is a 1 3, like that, right? Like that. So they communicate, they can communicate, and they can communicate. And I think this should be allowed, right? So answer should be 0. So you say we have 3 languages. The first one we can do this. Second one we have 2, 3. Third one we have 1, 3. You don't need to teach. They all talk to each other already. Yeah. You see? You don't have to teach. They all talk to each other already. So they don't all have to talk in the same language as long as they can talk to each other. And that's fine, right? Okay, so this means if you already talk to each other, then you don't have to teach another language. Right, this one they already talk to each other, so you don't have to teach. So the only one you have to worry about is the one that don't. So like here, right, 2 and 1, 3, they don't. So we need to teach one of them a language. So we can, I'm just trying to see if we can brute force this. That we pick a language, and then if you contain it, you just don't teach it. If you don't, you will teach it. Right? You will teach and you will teach. So I think the strategy does work. Basically, I'll pick out the nodes that cannot communicate, and then I say I'll swap it. But then the ones can communicate probably will get affected as well. Yeah, it will get affected as well. Maybe has let's go brute force. So let's say we'll teach, let's say if we teach language 1, what is the minimum number of people we need to teach in order for everyone to talk to everybody else? So now 1 is the common tongue, right? 1 is the common tongue. So if you're already communicating 1, that's fine. If you don't, then so what we do, we traverse this thing? No, we don't traverse the thing, we traverse the friendship. We traverse the friendship, and for each one, right, we have 2 nodes, so we need to know if they share. What's the length of each language? Small, so you can have like gigantic number. Maybe we can do pre-compute. Right, so 1 and 2, we want to know if they share anything. Right, if they share anything. And that's the thing, like if they do share, then we say, okay, we don't have to change. But then you do 1, 2, then 3, and then you say, okay, we have to change there. But in order to change there, you will have to change. Yeah, say 1, 2, they're already talking a language, and 2, 3, they don't. But we want to make change, right? So when we make change, it will affect, right? It will affect backwards. Can't think of a good way at the moment. It's been 60 minutes. I have no idea. Let's see the hints. Okay, yeah, I was thinking about it, but how? How do we do this? I don't know how. Like I was saying, if I want to pick a language to teach, and then what? Well, for the nodes that contain this language, we don't have to teach them. For the nodes that we don't, right, we can choose to teach them, and then we can get a number, right? But you don't have to. Right, I don't have to. So maybe we can say, before I teach, so I find a node that doesn't contain this language, right? And then I look into its neighbors. If it has a neighbor that contains this language, no, it doesn't. It doesn't. So what we want to know is if this node can survive without teaching this language. So I look to its neighbors. I look to its neighbors, and then we'll see. Actually, no, it's just like for this pair, do they share? Oh, hold a second. To teach, it doesn't mean to swap. That's a question. Like, if I teach, does that mean I add a language, or I have to replace the previous existing language? That actually is, because I was thinking you might have to swap. But if you want to swap, and then you can change the original state. But if you just like add a number into it, and that's a different story. How can we prove that? So let's say, yeah, it's hard to prove. So we need to have some already channel, and then we need to change language for this so that it can talk to somebody else. But then I can just change it to that. So that's also not a I don't know. If we just say we can just add additional, right? So if the two don't have, then we just add it. If the two can communicate, then we just leave it alone. If the two cannot communicate, then we just add it. That does make things a lot simpler. So I can implement this. Okay, I can implement this. Maybe that is what it's asking for. Okay, so now the question is, how do we decide if the two can communicate already? So we need to find if they have any overlap, right? If they have any overlap. if they don't have overlap, those are the ones that we need to highlight, right? So we pick out all the friendships that do not share anything, and then we will just brute force it, and we don't have to worry about the ones already. Okay, so that does make things a lot easier. I was thinking you have to swap a language you already know, but I don't think this is swapping. I think this is simply just, you can add a new language. But we'll make this point clear when we do this. Okay. So this solution is based on the assumption that once a person, when we teach a new language to a person, they will not forget any of the previous languages that they already speak. So we will go through friendships to find the edges that do not share any languages. Then we brute force each language and see how many people we need to teach. So when you brute force, right, you have a language. So if this person doesn't have it, you just have to add it. Yeah, this probably O(n) squared. I don't know, but most likely it is. So we will have a vector of int. So this is a index of no communication. So bad index. So we say for int I 0i smaller than friendship dot size I plus plus. So I need to decide if, right? So we say int a is friendship I 0, b is friendship I 1. So I want to decide if a and b, you know what? I should actually do this -1 and -1. I need to decide if a and b, they share any languages. How can I do it fast? How can I do it fast? You can do a dumb one. I wonder if we can sort. If we sort languages, then we can do it probably faster. So okay, let's sort it. So for auto L of languages, right, we basically say std sort L dot start, L dot begin, L dot end. So this will be O(n) squared log n already. Right, this is n log n, this is n. So we go through that, and then we need a function to check if they contain anything similar. So we say auto can communicate. Okay. We probably need to take this. Actually, I don't really think we need to take anything. No, I don't think. I'll just do this. So what we need is std vector int L1 vector int L2, right? So L1, L1 and L2 are both sorted we want to find whether they share at least one common element. So basic is kind of 2 pointers, right? So we just go. So we say int I equal to 0, j equal to 0. While I smaller than L1 dot size and j smaller than L2 dot size. Okay. If L1I equal to L2j, we will return true. Otherwise, if L1I is smaller than L2j, then I++, else I++, else j++, and then we'll return false. Right? So if it's equal, otherwise the smaller one will move forward. Smaller one move forward, smaller, and the first time coming out, that's bad. Okay, so now for this, we got A and B. So what we need to say is if can communicate languages A, right? And this is languages B. If they can communicate, then we'll skip. But if they cannot communicate, then we say bad index dot pushback I. So this is to find all the friendships that do not share a language. And then we need to go through every single language and to check if they exist in it. We can probably, I think, binary search to find. So C++ binary search find. Binary check the existence of an element in sorted range. Return true if found, false otherwise. I think this is exactly what we want. So what we can do is interest, right? Interest equal to n is the number of languages. What we want is languages.size plus 1. This is the maximum, right? And then we just say for int L equal to 1, L smaller equal to n, L plus plus. Now we'll go through every one and then just to see how many I need. So we say for auto F of friendship, right? Friendships, not friendships. Actually, no. So it should be int index of bad index. Right, and then we say int A shall equal to friendships index 0. B is friendships index 1. Okay? And then what we want to see is if data exists. If they exist, should be true. If they don't exist, it's false. So we all say int current is 0. Right, so we can use binary search to say current plus equal to std binary search languages a dot begin languages a dot end and language. So if it's true, which means that it exists, we don't have to teach. So it's, we'll do this plus exact same thing. Binary search. This could be languages B. dot begin, languages B dot end, and L. Right? If they don't exist in neither, then use of declared. I probably need to do this. Huh? How is it used? Oh, my bad, it's current. Alright, so blah blah blah, at the end we'll say res equal to minimum res and current. And at the end we'll return res. Alright, let's see if this one works. Oh, where? That's my bad. I forgot the -1. Woo! That is bonkers. So yeah, we'll pick out 1, 4. Right, we'll pick out 1, 4, 1, 2, and 3, 4. Right? So if I choose the third language, I choose 3. So 4, 0, 1, 4 has 3, so I'll teach there. Oh, I'm double counting. I am double counting. Ugh, I'm double counting. Which means if it has been considered already, you should not consider it. Yeah. Alright, it's fine. It's perfectly fine. We just need to scene, right? So vector boolean taught of size languages.size, right? False. So we have A and B, and then we shall say if languages A, not languages A, taught A, right? If taught A, if we haven't teach A, if not taught A, and this, right? If this and this, it has not been taught and it needs to be taught, then what we do is we'll say current plus plus and taught A equal to true. Okay, and then we'll do the same thing for taught B. Alright, this is B, 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 okay. So we add a little check. Alright, let's try this one. Sounds right. Hopefully it's right. Hopefully this is exactly how they want us to do. And I think it is how they want us to do. Yeah, you can add like more. That's definitely make things easier. Editorial, greedy. Ooh, greedy. If they do not decide, we cannot communicate. Yeah, in the first case, we do not need to do anything since the friends can already communicate. In the second case, we need to choose a language that both can learn, which will allow them to communicate. Our goal is to find a minimum number of people who need to be taught a language. To do this, we first identify all friends who cannot currently communicate. Yes, that's what we do. Next, we need to find a language that all of these friends could potentially learn. If they all share this language, then communication will be possible. How do we select such a language? We could count how many of the non-communicating friends already know each language. Oh, that's actually a good idea. And then greedy choose language known by the largest number of them. This minimizes the number of additional people who need to learn it and can be proven than choosing any other language. Okay, I agree. I think that is pretty smart. So basically you use a hash map to know the count, and yeah, you know the number of people, and yeah, this is good, but I'm not gonna implement it, but this is a good approach. I would just brute force it, which actually is not that good. Yeah. Alright, anyway, so this is good. I'll just leave it as is.